Hi everyone, today we're going to look at measures of spread. Let's have a look at a range, which is the highest number minus the lowest number. We have two groups of data here, Group A and Group B. They represent the test scores out of 10 from some students. We can't look for the range yet because if you look at the values, they're all jumbled up. We have to make sure they're in ascending order. So let's reorganize this. Now that we have the numbers from smallest to largest, we can take the largest number minus the smallest number, 10 minus 2, and that gives us the range, which is 8. We can do the same for group B, so the largest number 9 over there, minus 5, which gives us 4. So what does it tell us? Well, group A students have a range of 8, and we can see from the values that they scored between 2 all the way to 10. So that's a big range. So we can see that the numbers are inconsistent, whereas group B scored between 5 and 9, and you can see from the numbers they're more consistent. So generally speaking, we want a smaller range. Interquartile range. What is that? As the name suggests, we're looking for the range of the middle 50%. So for group A, we're looking at the range for that section there, and for group B, we're looking for the range of that section there. So the main numbers, not the tail ends. All the data is 100%. If we split into quarters, we get 25%, 25%, 25% chunks. So the interquartile range is looking at this middle two sections. A couple of terms that we're going to use to describe the data are largest number, we're going to call it the maximum. The smallest number, we're going to call it the minimum. And we know the middle number, it's called the median. Another way to represent the median is Q2. Now if that's Q2, you can guess where Q1 and Q3 will be. So Q1 is the middle of the bottom half, and Q3 is the middle of the top half. So the interquartile range is when we take Q3 minus Q1, and the range is when we take maximum minus the minimum. So let's try finding an interquartile range for group A. To find the middle, it's quite easy. You can count them here. But we're going to use a formula to represent the method so that you can use it for a bigger range of data when you have lots and lots of numbers. For the sake of this example, I've reduced the number of data so we can see how it works. So looking at these, we can see that there's 9 pieces of data, and to find the median position, we use a formula n plus 1 divided by 2. And there's 9, so 9 plus 1 is 10, 10 divided by 2 is 5. The fifth number, that's not the median, that's a position. So we count 1, 2, 3, 4, 5. So 4 is our median. Now that we have the median, we can separate the data into the bottom half over this side and the top half. For the bottom half, we can see that there are 2 middle numbers. When there are 2 values, we take the first value and the second value and we divide it by 2. So 2 plus 2 divided by 2 is just 2. The Q1 is 2. Now let's have a look at the top half. We have 5, 6, 8, and 10. So there's 2 values again. And 6 plus 8 divided by 2 is 7. Q1 is 2 and Q3 is 7. To find the interquartile range, we take Q3, take away Q1, so 7 minus 2, which is 5. Here we have a stem and leaf plot of the number of messages sent in a week by students. And the key tells us that these are tens, not hundreds, because the key says 1/2 represents 12 messages. The biggest value in this data set is 79, and the smallest is 5. To find the range, we take the biggest minus the smallest. So 79 take away 5 gives us 74. For the interquartile range, we have to find the middle, which is the median, and then the middle of the bottom half and the middle of the top half. So let's have a look how many numbers we have. We have 23 values. Using the formula for the median, 23 plus 1 is 24, divided by 2 gives us 12. Looking for the 12th number, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12th number is over here, 21. So the median is 21. Now we have a top half and a bottom half of numbers. So there's 11 values on each side. The 11 plus 1 is 12 divided by 2 is 6. So the 6th number from the top bit and the 6th number from the bottom will give us the Q1 and Q3. So let's count 1, 2, 3, 4, 5, 6. 10 is Q1 and 1, 2, 3, 4, 5, 6. 37 is Q3. And you can check. You can see that there's clearly 5 from the middle on this side and 5 along the other side. So again, the interquartile range is Q3 minus Q1. So 37 take away 10, which is 27. When we look at the distribution, we have to ask what type they are, because it was going to guide us to which average is best. So in other words, which measure of central tendency. And it's also going to answer our question to which spread is best, which is the range or interquartile range. Let's have a look at this example where I have the pocket money that 10 of my students receive a week. So there are 2 students who receive $5, most of them receive 10, and there's one kid who receives $100 a week. We can clearly see that the most number, or the mode, is 10, and the median for 10 values is the 5th and 6th number, which is also going to be 10. But the mean, if you add them all up, there's $180 divided by 10 is $18. So when the data looks like this, using the mean would be quite inaccurate, because the mean is saying that the average student gets $18. But really, we can see that a better average would be the median or the mode. We wouldn't use the mean because it has been affected by that outlier, that number out there. Instead of being 10, it has moved closer to 100, and that's why it's 18. Looking at the stem and leaf plot before, we can represent it like so and see that it has been skewed to the right, which means our median, which was 21, is a lot more accurate to describe this data set than the mean, which is 26. The mean has been moved towards those outliers. And we describe this shape as skewed to the right because all the numbers are trickling away to the right. This is called positively skewed. And you've guessed it, if this is positively skewed, the negatively skewed would have like a trail trickling numbers towards the left. These are called non-symmetrical distributions because they're not symmetrical. The mean in both cases are shifted towards their outliers. So the negatively skewed would have the mean shifted to the left, whereas the positively skewed was shifted to the right. And the range is also affected by the outlier. It's being moved further apart, so you get a bigger range. In non-symmetrical distributions, it's much better to use median as a central tendency and the interquartile range as a measure of spread. So with this non-symmetrical distribution or skewed distribution, we're going to use median and interquartile range. But for symmetrical distributions, we're going to use the mean and the range. Looking at the previous data, we can see that it is positively skewed. So we're not going to use the mean as a central tendency, we're going to use the median. And we're not going to use the range to describe the spread, we're going to use the interquartile range or IQR. And lastly, sometimes the data looks like this, where there's 2 values clearly as the modes. We call this bimodal. And if that happens, then it's very likely that you have 2 sets of data. For example, there could be students and teachers scoring at a sports event, and you need to separate the data before you can analyze it. That's it from me today. See you next time.